Okay, so number one, the diagram shows an xt or displacement time graph for a moving particle along a straight line. And the equation of motion is x is equal to t minus 1 squared plus 4. For t values from 0 to 4, find a the velocity at t equals to 1 and t is equal to 3. All right, so first things first. Okay, so from the previous chapter, chapter 22.1, we used to see particles moving on a straight line, right? Like this. Okay. Now, it's also similar with this. It's just that it graph this equation. So basically, this is quadratic. That's why we are forming a curve like this. All right. So anyway, let's answer letter A. So let's find the velocity at t is equal to 1 and t is equal to 3. So we have to solve it twice. But then, since this is a displacement time graph, we still need to find the velocity function of this, right? So there are two ways, class, actually. Um, the first one, if you still remember, how do you find the gradient of a curve? So for example, at t is equal to 1, so it's over here. So this is the first method or the other option. How do you find the gradient of a curve? So basically by drawing a tangent like that, right? So basically your gradient there is 0 because it's a straight horizontal line. And then let's say when t is equal to 3, so it's over here. So again, you should draw a tangent, okay, for that uh, point or yeah, okay, and then find the gradient of that line that you created or the gradient of the tangent. That's one way. Or another way is also, just like in the previous chapter, um, you can take the derivative of the displacement function, which is um, this one. Okay, so I think, okay, wait, let me erase something. So this is not dv, this is supposed to be dx. Okay. Okay, so getting the derivative of the displacement gives you the velocity function, which is 2t minus 2. By the way, I simplified this and it became t squared minus 2t plus 5. So anyway, we're here now. Okay, so at 1 second, so just plug in 1 in the velocity function. So that is 0 meter per second. That's the first velocity at 1 second. Now at 3 seconds, so the velocity is 4 meter per second. So just that. So again, this is another way, and then the tangent is also another way. So it's up to you which one you want to use. Okay. Uh, of course, if you want to be more accurate, I'll go for this. Okay, but if you want to, let's say, answer this faster, you can just draw the tangents, okay, and find the gradient of those lines. Okay, and then let's have letter B. So letter B, let's find the total distance traveled during the interval uh, for t values starting from 0 until 4, and hence the average speed uh, over this interval. Okay, so class, listen. Okay, look at this graph. Okay, so it's asking for the total distance, right? Now, if you're given a curve, okay, you don't have to find the area under the curve here. Okay, so just observe your graph here. Now, from 5, looking at the distance, okay, your curve went down 1 unit, right? It went down 1 unit. So this is at 4, correct? So let me write that here. So it went down 4, uh, let's say 4 meters, okay? So that's 1 meter already. So this is its maximum, or sorry, minimum point, right? Okay, so after the minimum point, everything goes up, right? Okay, so this is 1 meter, okay, plus what is the total distance? Plus this. Okay, so how many units from here to here. So basically, class, you just need to count 1, 2, 3, 4, 5, 6 until you reach this point, which is this one. It's 13, right? Okay, so this is 13. So from here until here, how many units is that? From 4 to 13. Okay, so it's 9 units. So to get the average speed, you need to get the total distance, right? Okay, so the total distance is 10 meters. Okay, how do we show that again? Now, if I'm going to show that in a straight line, your curve started at 5, right? And then it went down 1 meter, down 1 meter, and then it goes up again until 13, right? So this is the whole distance. Okay, so from 5 down 4, and then back to, going up to 13. So that's 10 meters. Okay, so that's 10 meters. And then divided by, sorry, let me write it again. So average speed. So what's average speed? So again, it's 10 divided by, okay, 4. So the average speed, by the way, it's 4 because of 4 seconds, right? So your answer here is 2.5 meter per second. So that's your answer for this. Okay, Sec 4, do you have any question? None? Okay, so let's go to number 2. Okay, so this one again is the unique from the first question. Okay, so this one has a sketching question. Okay, so let's have this one. So number 2, the displacement x meters of a particle from a fixed point O on the line is traveling given by x is equal to 60 minus t squared. Now, letter A, we need to sketch the displacement time graph. With the help of this graph, find the total distance traveled in the first 6 seconds. Okay, so class, I made this, or I answered this last night. So this is letter A. Okay, now I have some pointers here. How do we sketch this one quickly? Basically, what you need to do first is to draw your x and y, uh, making this your displacement, your x meters, and then this one is your time axis, so t seconds, right? Then after that, since okay, okay, so you ask these questions. What is this equation? This is quadratic, right? Because of this t squared, right? And it starts where? It starts on the origin. Okay, from the sentence. Okay, so it starts on the origin, and then uh, since this is negative t squared, where a is negative, right? That means that your curve is opening downwards like this. Okay, and then okay, we know that it's first 6 seconds, right? Okay, but then how do you find the maximum point of this curve, right? So basically, class, there's a little bit of steps here. So v is equal to 6 minus 2t. So what I did there is to get the derivative of the displacement function. Because in the maximum point, velocity is 0, right? So 0 is equal to 6 minus 2t. So therefore, it will reach its maximum point after 3 seconds, right? So let me label that here. So this is 3 seconds. That's why the graph is like this. So you can just put it there. And then, yes, it's 3 seconds. But how high is the maximum point? Or what's the distance or displacement of the maximum point from the origin? So with that, you're going to use the displacement function. So I just plug this 3 seconds here, and then you'll see that it's 9 meters. So yes, so it will reach its maximum point at 3 seconds at 9 meters. Okay, so basically class, so you guys 1, 2, 3, 4, 5, 6. Okay, and this is 3, and then it will reach this point after 3 seconds. So drawing the curve, so this one. Okay, now class, let's say you will only draw until this one. Now again, quadratic equations are symmetrical. So if the half is like this, that means that the half is just the mirror of the other half. So yeah, just to make it equal or symmetrical. Okay, so this is your sketch for letter A. Okay, and then what is the distance traveled in the first 6 seconds? What do you think? Okay, so from the origin, it goes up 9 meters and then it goes down 9 meters. So what is the total distance traveled? So basically, the total distance, okay, is equal to how many? 18 meters. Okay, so that's your answer. It's 18 meters. Okay. Okay. Now, if you're going to maybe draw this on a straight line graph like this, okay. So this is 0, and this is 9, right? So it went here. This one denoted by this. It went up, and then it went back like that. So it went down. Okay. So basically that's 18 meters. So 9 plus 9, so that's 18. Okay. So that's letter A. All right, so let's go with letter B. Now, for letter B, we need to find V in terms of T. So we just did that from letter A, right? Because to get V from the displacement function, we just need to derive this, which we did from letter A. Okay, and then in terms of T, and sketch the velocity time graph. Okay, so first class, we need to get the velocity function, which we have already. And then I just rearrange this like this. Okay, you remember this class? Okay, this is similar with, not similar, this is exactly the same as y is equal to mx plus c. This is your, what do you call this one? This one is the equation of a line, right? So m is your gradient and c is your y-intercept, right? So I rearrange this and make it like this. Okay, so -2 is your gradient and then -6 is your y-intercept, right? So how do we draw our velocity time graph? So basically, again, you draw your x and y's like this, and then label this as your v, and then label this as your t or time. Okay. So why did I rearrange this like this? So I know that this line here, because this is a line, right? It will intercept the y-axis at 6. So yeah, this is 6. So it starts here. So you can draw a point right here. Okay. And then I know, you remember vectors, right? So the gradient is -2, 1. Okay. You remember how to draw vectors? We start from 6 and then we go down 2 units, right? And then 1 unit here. Okay. That's why it's rise over run. So rise means going up, going down, and then running means going left or going right. So in this case, we start from here. Since this is -2 over 1, so we go down 1, 2 steps, okay? And then another step on the right because you have your positive 1 right here. So therefore, your next point will be right here. So I just extended that line to reach the T axis. So this is what? 3 seconds, right? Okay, so that's letter B. So you have sketched your velocity time graph. Okay. All right. So let's go to letter C. Is the particle accelerating or decelerating? Is it doing so uniformly? Okay. Basically, yes, it's decelerating because in your vector time graph, this gradient here represents acceleration, right? And then as you can see, if your gradient is going down, that means you have a negative gradient. Ergo, or hence, it's decelerating if it's going down. And yes, it's uniformly going down. Okay, because gradient is going down. Sorry. uh, gradient is down, that means acceleration is also down, or in other words, it's decelerating. Okay, so they're in a uniform, uh, or it's doing it uniformly. Okay, so that's it. That's a letter B and letter C. Okay, and then for your last example today, let's go right away to number 5. Okay, now number 5. So we don't have to sketch this. So there's a sketch right away. All right. So number 5, the velocity time graph shows the velocities at different times of a particle traveling along a straight line. Okay. Let's calculate letter A, the acceleration during the first 30 seconds. Okay, first 30 seconds. Again, this is your time. This is your velocity axis, right? Now, looking here, this is your 30-second mark, right? And then it is denoted by this line over here. That's the acceleration. Okay. Now, I just labeled them A and B so you guys can see the name of the line. Okay. Actually, you can put letters here: A, B, C, D, and E in every point. This is point, 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 and point. Okay. So again, the acceleration class, to get the acceleration of this, you just find the gradient of this line over here. So how do you find the gradient of a line? Okay, given this points A and B. So the coordinates of point A is 0, 10, right? And then the coordinates of point B is at 30 and 20. So using the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1, so you just plug it here, or plug those values here, and then your gradient is 1/3 meter per second squared. That means it's accelerating at 0.333 meter per square second. This one. That's why it's going up. So it's accelerating. Okay, so that's letter A. Now for letter B, we need to calculate the distance traveled in the first 70 seconds. How do we compute for the distance? Right? So this is the first 70 seconds, this one. Okay. So distance again, given your displacement time or velocity time, you just need to compute for the area below the graph. And it makes a certain shape, right? Okay, again, so the distance is equal to the total area under the shape or the graph. Okay, so basically, class, this is a trapezium, right? Okay, if you look at this, um, and then if you rotate your phone or device on your right, it will look like this, like this. Sorry, it will look like this. Okay, so this is your A, this is your B, this is your height. In this case, this is my A, this is my B, this is my height. And then this is one is, again, it's a triangle, right? So the total area of the shape is a trapezium and the area of a triangle. So let's compute for that now. Okay, so for the trapezium, it's 1/2 times A plus B times C. So A is 10. Okay, wait, let me zoom out. So this is A, this one. And this B is 20. Okay, the two parallel sides. And then the height is 30. This one. This is the height. And then, of course, times 1/2. And then for the triangle, so this is, let's say this is your base, which is 40. And then this is 20 as the height. And then times 1/2. So answering this, basically your answer is 850 meters. Okay, so that's the distance traveled in the first 70 seconds. So 850 meters. That's letter B. Now let's go right away to letter C. Now for letter C, it's asking for the total distance traveled in the 90-second mark. Okay, so basically we know from 0 to 70 seconds, right? So we just need to add this part right here. Okay, this line over here, CD. Okay, all right. So anyway, so this one we already got that from letter B. So I'm not going to solve that again. And then how do we find for uh, the distance of CD? So by finding the area of this triangle right here. Okay, so basically your base is 20. and then your height is 10, right? This is 10. So therefore, your answer is 950 meters. So from here until here, that's 950 meters. But then for letter D, you need to calculate for the displacement of the particle from the starting point after 90 seconds. So displacement class. Okay, so for displacement, in this case, this portion here is below 0, right? So if a displacement is below 0, that means it's negative, right? So we need to subtract this from the whole displacement thing, okay? Uh, so doing so, basically it's the same as this. It's just that since this is below the time axis or the x-axis, these are negatives. So you just subtract that, and then you'll get 100, right? So for letter D, your answer is 750 meters. Okay.